So the coordinates of w, x, y, z are listed there. It wants a translation after 6 units to the right and 3 units down. So a translation would be x to the right is plus 6, y 3 units down is minus 3. So all you can do is take these numbers and add 6 to the x and subtract 3 from the y. So you should come up with 4, 1, 0, 4, 7, negative 1, 10, negative 8. On number 2, you have to write the rule to describe the translation. So this is our original one. Our original one is there on the left. The new one is on the right. Okay, and those are listed by the primes that are there. And we're going from m to m prime. So to get from m to m prime, we go 1, 2, 3, 4, 5, 6 to the right, and 2 up. So right 6, up 2. So your rule would be x, we went to the right, was plus 6, y plus, because we went up, 2. You have to put the x and the y in there. If you just put plus 6 plus 2, that does not count. Number 3, draw the image produced when a triangle ABC is reflected in the y-axis. Here's our y-axis. We're reflecting across that, so we have to count from our point to the line of reflection. So it's 1, so another one right here, A prime. All that's happening is you're changing the sign of the x values here. 1, 1. B prime. C is 1, 2, 3, 4. 1, 2, 3, 4. C prime. On number 4, give the coordinates of the points after reflection in the x-axis. The coordinates are listed. It's not using the picture, it's using the coordinates that are listed. When you do a reflection in the x-axis, the only thing that changes is the sign of the y. So it's still 4. Instead of being 5, it becomes negative 5. Still 0. Instead of being 4, it becomes negative 4. Still negative 2. Instead of being 1, it becomes negative 1. Okay? On number 5, okay, the rule for a 90-degree rotation is negative yx. So you're changing their positions, and then you're changing the sign of the y. So A was at negative 4, negative 6, so I'm going to change their position, so negative 6, negative 4, 4. And then we have to change the sign of the y. So instead of being negative 6, it becomes a positive 6. Change their positions, negative 2, negative 9. Change the sign of the y value, the original y value. C, change their positions again. Change the sign of the original y value. So it would be 6, negative 4, 2, negative 9, 1, negative 3. Okay. Number 6. Okay, on number 6, it's trapezoid ABCD is rotated 180 degrees about the origin. The origin is right here. Okay, 180 degrees. This is 90 to this one is 90 degrees. To this one is 180 degrees. Okay? So, essentially what we're doing, the rule for 180 degrees is negative x, negative y. All that means is change the signs. So A is at 3, negative 2, so we're going to go to negative 3, positive 2. A prime. B is at 9, negative 2, so negative 9, positive 2. B prime. C is at 4, negative 5, so negative 4, positive 5. Let's see. D is at 7, negative 5, so negative 7, positive 5. D prime, and then we connect them in order, just like that. On number 7, a dilation map 610 to 3,5. What are the coordinates of the image of 12,4 under the same dilation? So the first thing we have to do is determine our scale factor. What do we multiply by to go from 6 to 3? To go from 6 to 3, we would multiply by...
Wait, 6 to 3?
6 to 3. 0.5. 0.5 or 1/2. Okay? So then we would take that and we would multiply it by the 12,4. So half of 12 is 6. Half of 4 is 2. So the answer would be A. 6, 2. Number 8. Triangle ABC has vertices of 1, 2, 2, 3, and 3, 1. Triangle DEF is a dilation of triangle ABC by a scale factor of 3. Sketch and label triangle ABC and triangle DEF on the graph below. Okay, so triangle ABC, A is at 1, 2, B is at 2, 3, and C is at 3, 1. So then we're going to do DEF. We're going to take the original coordinates and just multiply by 3. So 1 times 3 is 3. 2 times 3 is 6. 2 times 3 is 6. 3 times 3 is 9. 9 times 3 is, 3 times 3 is 9. 1 times 3 is 3. So those are our new coordinates, and we just graph them. 3, 6. That would be D. 6, 9. E. 9, 3. F. D, E, F. Okay. Number 9, give a sequence of translations, reflections, and or rotations to get triangle ABC to triangle EDC. You could do this one of 2 ways. Okay. The first way would be a rotation of 180 degrees. 180 degrees around C. You rotate it around that thing 90, 180. Or you could do a reflection over the y-axis, and then a reflection over y equals 1, which is this line right here. Wherever the line that goes through that number on the axis is what we call it, so that would be y equals 1. Or you could say / segment CD. Number 10. Brooke transforms a right angle using rotations, reflections, and translations. Is it possible that Brooke's final image is an obtuse angle? Explain. If we rotate, reflect, or translate any shape, all we're doing is moving the shape. We are not changing the size of the shape. Does everybody understand that? Okay, so, no. Brooke's image cannot be an obtuse angle because reflections, rotations, and translations are rigid motions. That means they don't change the size or shape of a figure.